I want to know if it's fast enough, if it works well enough so that we can use EFS with Lambda to store any code base, PHP, vendor directory, or the JavaScript node modules directory. On AWS Lambda, you have some space. You can deploy a code base, but it has to be under 255 megabytes. Maybe we can use EFS to increase the size of the file system and deploy larger code bases. So to get started, what I did yesterday, I managed to create an elastic file system in EFS. So that was pretty straightforward. Basically, I did create file system. What's really great is, just like Amazon S3, you don't have to choose a size for your space because it's unlimited. You only pay for what you use. So I have created the EFS file system. I have created an EC2 box. EC2 is a server. I did connect the EFS and mount the EFS file system into the EC2 box. And now what I will do is connect to that EC2 machine and just create a few files, just so that we can start playing with actual data. Hello world. And hopefully, if I mount that inside Lambda, I will be able to read that file. So let's do that. I haven't created any Lambda function. So what we will do, and I don't know if it will work, but let's give it a try. We'll go into Lambda, create a function, tmp test EFS. And you know what? We'll try to use Node.js, because why not? I think there's a new section in the configuration panel where we can add the file system. Here, the file system thing. EFS is an NFS file system. And what they do is they run that inside a VPC. And VPC is a virtual private network on Amazon. So they have virtual private networks to secure, to make that the EFS file system is not accessible from anybody online. So the file system is only accessible from inside the virtual private network, which is called the VPC. We have to put Lambda inside the VPC to be able to mount the file system inside Lambda. So let's add the VPC. Here I created the EFS file system inside the default VPC, and I'm going to use that default VPC. Let's hit save. Right, I remember that. That's why I never use the Amazon console, because using the console, there's so many things that you have to do to set up stuff that I always forget about it. Here we have to set up permissions. So you know what? Let's drop this idea altogether and create a function using a tool like the serverless framework. I will actually be creating a Bref function, so it's not really about Bref this stream, but at least it will just work. I'll install Bref. Yeah, there you go. So I'm installing Bref. I will create a PHP function, but what I'm testing right now could work with any language. There's just composer.json vendor. What I will do is Bref init. So now it has created for us two files, index.php and serverless.yaml. So serverless.yaml is how we configure what we want to deploy, and index.php is our application. Index.php is a lot of HTML stuff that we will remove. It's just a hello world. And we'll start with that. Serverless.yaml makes it easier for us to set up VPC stuff because when we deploy with Bref and with internally the serverless framework, it will create the right permissions for us. So just by putting that, I'm saying deploy my Lambda and use that VPC configuration. Serverless deploy. So we have deployed our application and we should see our hello world. Perfect. That's the one I created just right now. And the VPC should be configured. Yeah, it's all configured for me. That's perfect. Now, hopefully I can add the file system. So I'm just clicking the default here. Okay. Seems to be good. This is a really nice way to deploy just the code. It's much faster. It's usually a few seconds. Okay, so there's nothing there. I just want to make sure that I don't have an error. So I will be doing bref dashboard. Run the serverless logs command locally. I like to use bref dashboard. Okay. The file does not exist. Oh, now there's a test directory. And it's empty. So it seems like mounting the file system. Maybe that's why. So I'm going to do something different. I'm going to create a readme.txt file in the test directory. Second file. Just to make sure I know which one is actually displayed. Okay, so that works. That's pretty cool. Because here I'm reading a file that I created from my EC2 box just a second ago, and I'm reading that from Lambda via the Elastic file system from Amazon. So that's great. So now what we can do is create, I don't know, we can just first try to have a look at the performances. So let's say I refresh that several times and I have a look at the logs. In the logs, we can see the execution time for the code. So I will wait a few seconds and the logs should display here. So I refreshed several times and it was like around 22, 10 milliseconds, 8 milliseconds, 7 milliseconds. Now what we can do, this is a really quick test. It's not really a benchmark, but I'm just removing the read of the file, saving. I refresh a few times and I want to see if there's any difference in terms of response time. 1 millisecond. Okay, it's definitely different. We went from 8 milliseconds to 1 millisecond to read a single file. Now, what I'm measuring here is just the execution time of PHP itself. So there is no HTTP connection going on. There is no network time involved. It's just the straight up PHP execution time. So we could try to run packages, like have a vendor directory inside the EFS file system and include that from index.php. That way it will be like simulating what if, because what I want to do is to try and see if that extra space that we can get now, we can use it to deploy larger applications. And I will require a package. I don't know which one, like I would require the command mark package. And this package turns Markdown into HTML. So it's not a huge package, but it's still, there's quite a few files in there. Actually, I'm going to do something much simpler. File system. I'm installing the Symfony file system, okay? And we are going to copy our vendor directory into, I think that was that path. So whenever my Lambda runs, it will copy the files, and I think that's I expect it to take a few seconds, which looks much better now. It's slower. Much slower, which is also a good indication of how fast or slow the file system actually is. Because if it takes like 20 seconds to copy the whole vendor directory, it will not read the files in less than a second. And we finish with an error. Maybe it was because we timed out. Yes, that's it. So it means that copying the files was so slow, that it timed out. So I will try with a different configuration. That's interesting. But that being said, I'm looking for a cheap way to store the vendor directory or any kind of application in there So even if with cheap settings it doesn't work, that's not really promising. But let's give it a try. Let's try for a more expensive approach. Here I'm in a bursting mode, which is the performance will be proportional to how much I'm storing in there. I can use provision a value of 10 megabytes per second. So that could be up to $66 per month. So I need to remember to disable that after the stream. I will remove everything. Okay. Okay, it finished. Which is still better than before. So it did make a difference. What I wanted to see was the time. So let's have a look at the logs. And it ran for 25 seconds. So it's not really good. I mean, not for that specific use case. Of course, if you have workers who are running in the background, processing jobs and files, I think that's perfectly fine. You don't really care if you have like 5 or 10 or 20 seconds more, if it helps you scale and process the file in parallel or whatever you want to do. But for actually running websites, not that good. So now what we're going to do is to try and use that vendor directory. So let's now try to use the Markdown library. So I'm creating the converter and I'm going to convert that into a title in HTML. And that looks good. And we get a title. So that's Markdown turned into HTML. We can have a look. So the whole thing worked and it took 2 seconds, which is from experience 2 seconds for a cold start, because we deployed, so it's recreating the Lambda, it's a cold start, but 2 seconds is a bit too much. If we refresh, however, yeah, I was expecting that to be fast, because again, I've read that the file system calls, the read calls are cached, not the write. The good thing is that it works, but I would say that it's probably not good enough to use it to actually deploy your application or extra code inside EFS and use that, yeah, to serve code. The first call is really slow. We have like 2 seconds of cold starts, and that's not even a large application. It's just just loading a few classes. There's still a way to go to try to run large files. Yeah, it could be a big buffer when you're processing stuff. It could be a good way also to share stuff with a legacy system that's running on EC2. I don't know, maybe you're storing images, avatars, PDF reports, whatever. And usually in those applications, you only need to access 1 or 2 files in a single request. Like you want to display an avatar or change it, like upload a new avatar or generate a report or just download it. So using EFS with that, even though there's a slight overhead for a single file, I think it's good enough. I think the problem lies with the fact that if you want to read a lot of files in one request, then that's where it may not work well. Yes, I think Amazon S3 is much better in most cases, but if you have a legacy system, that's running somewhere and that is generating files and it needs to be on the disk, and people use EFS today mostly because of code that needs to write and read from a file system. So that's where it could be useful. Okay, so thank you for following the stream. That was the first time today, and I think it worked well. Maybe I'll do that again next week. Bye-bye.